Hey everyone, in this video I'm going to remind you how to build an exponential model. So here's our example that we did in class. So we're telling our reader what we're looking at. We're reminding ourselves our x-axis represents days since the peak interest. T equals 0 right here is our peak interest on Google Trends, and our y-axis is that rating out of 100. You will have a completely different x and y-axis, but I'm just reminding you of what we're looking at. And we have our data saved in Desmos. So now we are ready to build our exponential equation. So we always start with our building block. Y equals a times b to the power of x plus c. In this case, Nellie decided to do interest according to time, so that's why you see an I and T here, but you can just have a y equals, and you can make this x to remind yourself that that's your x-axis. The first thing you're going to do is set your c value. A friendly reminder that the c value represents that height of the asymptote, that leveling off point. So the reason we decided that our best guess was kind of 7 was if we go in, and let's make my y-axis go by 1s or 2s. Maybe 5s. Well, there we go. And I'm looking for that level off point. Some of you might not have level off points, and you're going to have to be creative and just follow your trend and estimate where it levels off. And our class saw that that level off point was, it seemed somewhere around 7. That looks like a good leveling off point. And so we set our C value to 7. The next thing you're going to do is estimate your y-intercept to help you get your A value. So if we estimated this trend, we would estimate a y-intercept. It doesn't have to be the point actually on the line. You want it to follow your pattern. So if I follow this pattern, we decided in class to set our y value to the point 0, 70. So if we put that into our building block, we would have 70 as our y value and 0 as our x value. And then subtract 7 on both sides, so we get 63 equals a. B to the power of 0, anything to the power of 0 is just 1. So therefore, a would be 63. So now we're almost done. We have y equals 63 times b to the power of x plus 7, and we just have to find our b value. So you're going to show an example. Pick any data point. So in this case, we picked the point 254. And 54 is our y value, and 2 is our x value. So when we substitute that in, it becomes 54 equals 63 multiplied by b to the power of 2 plus 7. Then we're going to use our order of operations, go from weakest to strongest. So first subtract 7 on both sides, then undo our multiplication by dividing both sides by 63, and then take the root, whatever that x value is, of your fraction. You can leave it as a fraction, and then we get an estimated b value. We could also do that with other data points. So for instance, if you took the point 12, 670, that is what it would look like, and you get a b value of 0.622. But once you've done an example calculation, then you should go into your spreadsheet that we created in class and enter your own data, and then it should recalculate your b values for you, and you can just take the average. So once you have your average, we have the equation of our line. Our average b value using all of our data points was 0.877. So you would have your a value, 63 times b to the power of x plus c. And if we put this into Desmos, we can double check it fits our data. So I have y equals 63 times 0.877 to the power of x plus 7. And it fits our data really well. Let me double check that average b value. 0.877, yep, or 0.88. A friendly reminder that as you go on to discuss your findings, one thing you can do is, obviously you can change the color of this and the texture to whatever you desire. You can also change the projector mode on here, and you can fix your scaling if you wanted to. Remember to label each of your x-axis and your y-axis in that corner as well. Your b value represents your percent increase or decrease from 100%. So in this case, rounded up to 0.88, this would be a loss of 12% per day. every day. And that is a reminder of how to create your exponential equation. I'm going to press save and make sure that's saved for us.